Hello, and this presentation is part of my study on antenna, and the presentation's topic is antenna input impedance, reflection coefficient, and VSWR voltage standing wave ratio. Here antennas work as a bridge between circuits and free space. So when transmitting, they take guided signals from the circuit and turn them into radiated waves. And when receiving, they do the opposite, capturing waves from the air and sending them into the circuit. Here, this diagram shows the full flow from the source through the transmission line, antenna free space, and finally to the receiver. Now, let's talk about what affects the antenna's input impedance ZA. First, the shape of the antenna matters, like a bent dipole behaves differently than a straight one. So second, the feed point, whether it's center fed or edge fed, also changes the impedance. Third, nearby objects like randoms can shift the impedance by altering the surrounding fields. Here, randoms refers to protective covers placed over antennas. And finally, frequency plays a key role because it affects the wavelength and antenna behavior. In this slide, for efficient power transfer, the antenna's input impedance ZA should match the transmission line's impedance Z0. The reflection coefficient gamma is given by this formula gamma equals ZA minus Z0 by ZA plus Z0. If ZA equals Z0, then gamma becomes zero, meaning no signal reflection. A typical value for transmission line impedance is Z0 equals 50 ohm. Here, reflections happen when there's a mismatch between the antenna and the transmission line. The reflection coefficient gamma is defined as the ratio of reflected voltage to incident voltage, like gamma equals V minus by V plus. And here S11 is the measure of how much power is reflected in given in decibels. And a low S11 value like below minus 10 decibel means low reflection and indicates good antenna performance. Now, VSWR voltage standing wave ratio. So here VSWR tells us how strong the interface is. Like it's calculated using the formula, it's calculating using this formula. In the best case, VSWR equals one, which means perfect matching and no reflection in the worst case PSWR goes to infinity, meaning total reflection and zero power transfer. Now, reflected power shows how much energy is wasted due to mismatch. So it's calculated using reflected power equals gamma square into 100%. A good design keeps gamma small, so very little power is reflected and most of it is radiated or received efficiently. In this slide, this table shows practical values of VSWR, reflection coefficient, gamma, and power loss. For example, if VSWR is 2, about 11% of power is reflected. At VSWR equals 3, the loss increases to 25% here. So our design goal is to easily and our design goal is easily to keep VSWR less than or equal to and S11 less than minus 10 decibel to ensure good performance and minimal reflection. So here's the summary. To design a good antenna, we follow three key rules. First, match the antenna's input impedance to the line, ideally around 50 ohms. And second, keep S1 on below minus 10 decibel across the operating frequency band. And third, aim for a VSWR close to 1 to minimize reflections. And all of these help ensure maximum power is delivered to the antenna instead of being reflected back. So this is it. Thank you for listening.